Hey guys, Mrs. Traber here. We're going to walk through our notes on section 4.6 on functions. Before we start talking about functions though, in order to define it, I need to define something else first. So we're going to get a couple definitions down. Our first one is relation. It is the collection of ordered pairs. So ordered pairs meaning those x, comma, y's. So a relation is a bunch of those as a group. And then a function is a relation where every input to that function has exactly one output. So it's kind of like a machine. You put something in, you get one thing out. You don't put something in and get two different things out. So that's going to be the mantra here. We're going to create a T-chart here where we look at things that are functions and things that are not functions. And we're going to look at it in 4 different ways: as a map, as tables, as ordered pairs, and as a graph. The first one to look at is as a map. So if I can imagine, I've got these inputs, 1, 2, and 3. And we're going to be using the terminology input today. In the next video, we'll talk about thinking of inputs as domain and range. So these inputs are going to have something happen to them in the function and then be delivered as outputs. And here's the deal: if my each input only goes to one output, so if 1 is mapped to the number 4, and if 2 is mapped to the number 5, and if 3 is mapped to the number 6, then this is a function because every input goes to only one output. On the other hand, things that are not a function are those where an input goes to more than one output. So here it is: 1 is going to both 4 and 5, and then it doesn't really matter what else happens. But right here, because the 1 went to both 4 and 5, it is not a function. So there's examples of functions with mapping. Let's look at it now as a table. So an XY table could be used here. Say I had an XY table that looked like this, where it had the points in the X 2, 4, and 6, and the points in the Y 4, 8, and 12. Notice here, because there's a different number in for every X, we're good. It could have even had 2 4s here or 2 8s here or something. It doesn't really matter if 2 different X's go to the same Y. It just matters if an X goes to more than one Y. So this one works. Here's one that wouldn't work. Actually, let me give you one more example of one that does work. I could have 2, 4, 6, and they could all go to 3. That would be fine because 2 only has one output, 4 only has one output, 6 only has one output. So these are both fine. Another example could be of one that is not a function. So say I had -2, 0, and 2. Actually, let's make them both positive 2. So both these positive 2's are going to head to the different points. This positive 2 heads to 4, and this positive 2 heads to 6. Well, that's not possible because I've got an input that goes to a 4 and that same input that goes to a 6. That won't work. So that is the deal with tables. Let's look at as ordered pairs. So here's a list of ordered pairs. I set it up in set notation. So this is the set. This is the relation of these collection of ordered pairs: -2, 6, 0, 10, and 1, 12. Notice -2 only goes to 6. There's no other -2 going to something else. 0 only goes to 10. There's no other 0. 1 only goes to 12. There's no other 1 for the X term. So this set of ordered pairs is a function. On the other hand, again, here is a set of ordered pairs that is not a function. Notice that we have the point 3, 5, and then over here we have the point 3, 10. That X coordinate 3 is heading to 2 different Y's, and that makes it not a function. The last one we're going to look at is that of graphs. So let's do that, then we'll be all set. So graphs can look a few different ways. We talked about linear versus nonlinear. All linear and nonlinear are functions. So no matter what, they're all going to be on this list. So we've got lines, we've got parabolas, we have cubics, we have those that are exponential. We also had some that were like hyperbolic, where they had asymptotes in there. So all of these are actually functions. And the way we know is that if I kind of thought about what is going on the xy axis, if I trace through, each x only goes to one y. So this x goes to this y, this x goes to this y. Same thing here. This x goes to this y, this x goes to this y. Every x only has one y. So what I can kind of do here is trace through, looking at it. If I kind of put my pen through it, I'm only touching it one time if I were to go through the intersection. So if you can think about taking a vertical line through at any point, if it only hits it once, and notice this one, it only hits it once every spot. All of these, that's the case. So in this case, we can run a vertical line test, is what it's called. And these ones all pass the vertical line test because they only pass that vertical line one time each. Some graphs that don't pass the vertical line test are those that'll run through it twice. So say I had a parabola that was faced this way. That's going to go through my vertical line in two spots, so that's a fail. I could also have a absolute value equation like this, and that's, again, going to go through the vertical line twice in some spot. If we had a cubic that was going the other way, then this is going to hit it twice, so that's a fail. We also have circles and ellipses. That's going to go through it twice, so that's a fail. So these, the vertical line test, these are fails on those guys. So we've looked at functions in several different ways now as maps. We've looked at them. We've looked at them as tables, as ordered pair groups, and as graphs. So hopefully all of these different representations will help you guys out. There will be a copy of these PDF notes online for Classroom. See you next time.